Okay, Assalamualaikum warahmatullahi wabarakatuh. In my previous video, actually I have gone through a little bit about concept that have been discussed in chapter number 11, slope deflection method. The concept about the joint moment, where joint moment is actually the moment that we distribute, and why when we distribute we put negative. Okay, joint moment is always opposite with member and moment. And then I have also discussed about the moment at the rigid joint in the frame, as well as moment at internal support. Okay, and the concept about frame. Okay, side sway frame. We have frame without side sway, and we have a frame with side sway. So how to identify the frame, whether the frame is considered as non-sway frame or side sway frame, I have actually explained in my previous video. So basically there are two reason. Okay, two reason for non-sway frame. Number one is properly restrained. Properly restrained means that there is a restraining force, okay, which comes with support, so it is properly restrained. Okay, number two is symmetry. Symmetry due to loading and geometry. So I actually pick this question. This is actually flexibility method question. Anyway, we can analyze this frame using moment distribution method, because when we look at to this diagram, so we have frame A, B, C, D. A is fixed. D is pin support. D is pin support. This frame is subjected to triangular load. Yeah, triangular load. Okay, along member AB. Okay, this triangular load is W. So in actual diagram, okay, in this actual diagram A, this frame is unsymmetry. Okay, this frame is unsymmetry due to loading, because we can see clearly that this is not symmetry, because there is only one member has the load. Okay, the load 750 kilonewton per meter. This is a triangular load, and so it is not symmetry. And there's no P. It is only subjected by W. And due to this unsymmetrical condition, this frame will tend to sway to right direction, because W is located along member AB, and we can see that the loading, okay, will push the beam, the frame, to right direction. Okay, because delta in frame side sway means that side sway is displaced horizontally. Side sway means displaced horizontally. So in this diagram, in this main diagram, this frame has combination of W, which is external loading, and delta, which is side sway. And we have to analyze W and delta separately. We cannot combine FEM due to W and FEM due to side sway together. So in frame analysis, we have to do separate table. So in each table, we have to analyze fixed end moment. Fixed end moment. So there is a formula to calculate fixed end moment due to triangular load, okay, which we can find in appendix. Okay, and that is for the first table. And we have to assume FEM value for second table for side sway frame analysis. So in this session, I would like to continue how to analyze second table. Okay, side sway frame analysis. But I need to revise a little bit about what is actually occur. Okay, it is based on the principle of superposition, where we have to separate between W and delta. So in order to separate between W and delta, what we need to do is we have to, okay, the first diagram, in order to remove the delta from the system, we have to put an artificial support at C. So due to that, the frame will become properly restrained. The frame will become properly restrained. So when the frame is properly restrained, it means that there is a restraining force R. Restraining force R. Okay, there is a restraining force R. Okay, properly restrained means there is a support. Okay, that brings us the horizontal reaction. Okay, so by putting an artificial support at C, so we actually remove the delta from original system. So by having this B diagram, we can solve this. Okay, solve this FEM, or solve this fixed member and moment. Okay, member and moment by considering only W, because we have removed delta, okay, from original diagram. And then in order to fulfill principle of superposition, we have to neutralize R. So we need to have another frame, but okay, this frame is subjected to R in opposite direction, so that negative R plus R equal to 0. Okay, this is actually based on the previous, okay, this based on this, where it is W plus delta is equal, it is original is W plus delta. So here we have W, and here we have delta. Okay, so the idea is okay, we have W plus, we have here W plus 0, and we have negative R plus R. So that is the idea about the principle of superposition. So in diagram C, okay, we can see that, okay, there is R restraining force in opposite with the one that we that is exists due to the artificial support. So due to this R, okay, due to this R, okay, the frame is tend to side sway. Okay, tend to move to right direction. Okay, that and there's no W, there's no external load. There's no external load. So in this diagram, okay, we will continue to analyze the second part of analysis, which is the second table. But one thing you must understand is, okay, if in diagram B, we analyze the member and moment due to the real value which is given in the question, the real value that is given in the question. But for delta, we do not know the delta value. Okay, in frame with side sway, we do not know the delta value. So we cannot calculate as easy as beam with support settlement. Okay, we cannot calculate FEM. FEM we cannot analyze frame with side sway as easy as we calculate beam with settlement, because in beam analysis, beam with settlement is always given in the question. Settlement value is given in the question. So when settlement is given, then we just need to use formula, substitute the delta value, then we get FEM due to settlement. But in frame we cannot do that, because the delta in frame, so the side sway in frame is unknown value. So because the delta is unknown, so we actually cannot analyze this diagram C. Okay, diagram C, we cannot analyze it directly. Okay, so the delta in C, we do not know the delta value. So when we do not know the delta value, we cannot calculate FEM. We cannot calculate FEM. So without FEM, so we cannot calculate the member and moment in C. So actually, what is explained in the textbook, and I have actually explained about that in the video last 2 days. Okay, what we actually do is we have to introduce another diagram called as D diagram. Okay, called as D diagram. So we have to introduce the diagram. So this is actually what have been explained in the textbook. So we have to introduce another diagram which is proportional with diagram C. Okay, where is proportional with diagram C? So whatever that you can see in diagram C, you duplicate. You need to duplicate. So you have fix and pin. Fix and pin here. Okay, whatever that you have in diagram C, you must duplicate. So this is diagram D. Okay, this is separate item, separate item, because after this we will actually interpolate the value. So this is separate item. Okay, C and D. So whatever that we have in C, we duplicate in diagram D. So diagram C, diagram D, we have, okay, this is actually R prime. Okay, we duplicate, but we add prime to every label that we have. Okay, so we will have delta. So if R we change to R prime, so delta we change to delta prime. Okay, so we have, okay, so this is delta prime. Delta prime. Okay, delta prime. So actually, we have two tables. Table number one, we focus on FEM due to loading. Table number two is FEM due to side sway. So FEM due to side sway, we have C and D, but we actually don't analyze diagram C directly, but indirectly we analyze diagram D. Okay, and since we do not know the delta value, and we do not need to establish or determine the delta value, so what we will do in diagram D is actually assumption of FEM value. Assumption of FEM value. Of course, in the video that I have made last 2 days, I have explained about FEM due to delta. Okay, start from FEM for beam, and FEM for beam for vertical, for horizontal member, and this is frame. So frame there are column, okay, column AB and column CD. So this the vertical member. So if the frame is tend to sway to right direction, so we will have the triangular, this triangular and this triangular, means that for column we will have the horizontal displacement. Okay, So FEM due to deflection, due to delta, is actually the behavior in order the fixed end moment actually will push the new uh, position of column to the original position. So same goes to what happened in beam due to loading. FEM, FEM is actually the reaction, the moment that will push back the band beam to its original position, which is straight position. So same goes to beam with delta. Beam due to settlement. Settlement for beam delta is vertical. Beam delta is vertical. So the new position is this one. So fixed end moment will push the new point here to its original position. So to its original position, we will get the moment, the purple one. The purple one is actually the behavior towards the delta. The delta. So if the member is horizontal. So what happened in frame is the member is vertical. The member is vertical. After side sway to the right direction, it will be like this. So we complete as one triangular. So this is the delta. This is length for the member. And the new position is the incline, the incline line. This is the new position. And the moment always push push the point, this point to its original position. So we have moment like this. We have moment like this. So we will apply this principle in our assumption. So the red one is representing FEM. The red one is representing FEM. And FEM is negative whenever the beam, the column is moved to right direction. Beam move to column move to right direction. It is FEM must be negative because we have to apply moment counterclockwise in order to push back the bend, the inclined column, to original position, which is straight position. Yang ni, this is new. This is original. Original. So the moment will push, we will apply moment to push back the column to its original position. So the movement is in counterclockwise direction. So FEM is actually counterclockwise. Whenever, the chord rotation, actually here we can measure the chord rotation. We call it as chord rotation, the angle. So we can actually conclude that when angle is positive, FEM is negative. That is how we conclude the FEM between FEM and the angle. So chord rotation clockwise, FEM will be counterclockwise. So same goes to beam. From original is horizontal. New one is the inclined one. The angle is positive. FEM is negative. So we have to understand about that. Uh, this one must be understand because not all condition the frame is tend to sway to right direction. In some condition, maybe the frame is tend to sway to left direction. So if frame is tend to sway to left direction, it will become like this. So when frame is tend to sway to left direction, this is the delta. The angle counterclockwise. The moment will be clockwise. moment, the fixed end moment. So just remember this. Okay, between chord rotation, chord rotation, we always measured from original position to new position, and angle is opposite with FEM. Okay, we go back to this one. Okay, so for frame in diagram D, so the angle, okay, the angle is positive. Okay, the frame is tend to sway to right direction due to the R prime, so the original is vertical. Original is vertical. Okay, original is vertical. So we measure the angle. We can actually measure the angle from vertical. And same goes to this. So the angle is positive. The angle is positive. So FEM must be negative. FEM must be negative. So the FEM assumption that we made must be in right direction, because if we put the wrong sign in FEM that we assume, we actually the frame actually collapse. Okay. Okay, so the first thing to do is we have to assume FEM. Okay, now we want to focus on diagram D. Okay, we want to focus on diagram D. So this is 7 meter. This is 5 meter. This is 7 meter. And for column, it is 2 EI. This is 2 EI. And this is EI. So we focus on this diagram. And in this diagram, we have, this is fixed end, this is pin, okay, pin like this. So this is actually the diagram that we will analyze for diagram, for table number 2. For table number 2. So we have to make assumption. So we have to assume FEM for member AB, which is equal to FEM BA, because both ends are fixed. Okay, this is equal to negative 100. Negative 100. Okay, 100, the value is not important, but the sign is most important. This negative sign is compulsory. Okay, 100, this 100, actually you can put 1000, you can also put 10, you can also put 1, but remember that this value we will use in the table. So if we use, for example, 10 or 1, because in the table we distribute moment until the moment reaches 0 value. So if we put 1000, so means that we will have to have maybe 20 cycle or 30 cycle, then we will get 0, we will reach 0 value. But if we use, for example, 1 as the assumption or 10 as assumption, we may have the cycle to distribute, maybe we need to only distribute 1 or 2 times. So the distributable value, okay, as suggested by the by Hibler in the textbook, is 100. So we just need to follow this. Okay, but please okay, make sure that the sign that we put is correct, because if frame is tend to sway to right direction, we put negative because of the behavior. If frame is tend to sway to left direction, then we have to put positive because of the behavior. Okay, so what is the formula to calculate FEM for AB? Okay, we have to refer to the formula. The formula is very simple. It is actually like this. So 6, okay, we have 2 EI for member AB, 6 EI delta prime, 6 EI delta prime over L, and L is 7 square, 7. Okay, 7 square. So this one, I put positive here to represent the angle, because the angle is opposite, okay, with FEM. Okay, so actually what we do in this stage is we want to determine the ratio between each member. Okay, so we have to simplify this as negative 100 times 7 square. Okay, divide by 6 times 2. 6 times 2. So this is actually EI delta prime. So this EI delta prime, we will use this whenever we calculate FEM for CD. FEM for CD. Okay, FEM for CD, it is the formula, the angle is positive. It is 3 EI. This is the formula. 3 EI, 3 times 2, because for member CD also it is 2 EI. EI delta prime divide by 7 square. So what we need to calculate now is to calculate FEMCD. Okay, FEMCD. So we need to substitute. Okay, so this is 3 times 2 divided by 7 square. So we substitute negative 100 times 7 square divided by 6 times 2. So we get this one cancel. This one also cancel. So this is 1, this is 2. Okay, so we get negative 50. We get negative 50 kilo Newton meter. So this is actually the value that we will put in the table. Okay, this is actually the value that we will put in the table. This is the value. Okay, the value that we will put into the table. Okay, this is the value. This is the value. So we move to the table, table number 2. So I have actually, okay, I have done this table this morning. Okay, this is table number 1. Table number 1, FEM, I have, okay, actually calculate based on the, okay, based on triangular load. This is the triangular load. Okay, you please watch the video that I have made this morning. So now I want to continue with table number 2. So we have the same table. So I just need to copy this. Okay, we have table number 2. Okay, but this time FEM will be changed to, okay, I have explained this morning how we calculate K and DF. So now I have changed to the FEM that we have made assumption. This is negative 100. Okay, negative 100. And there's no FEM for member BC since there's no vertical settlement in beam. Okay, here is negative 50 and this one is 0 because it is pin support. It is pin support. So like this. Okay, so we will start the first distribution. So I will clear this part first. Okay. So for the first distribution, so remember that the moment that we distribute in the table is the member and moment. So FEM is actually the first member and moment in the table, and member and moment is opposite with joint moment. That is why we have to put negative. Okay, negative in the table means that, okay, it means like this. Okay, so this is joint B. So we have negative 100. We have negative 100, and this is AB. This is BC. And since there's no value from BC, and the moment that we distribute is actually the opposite value, the opposite moment. Okay, because joint moment is opposite with member and moment. I have explained about this concept, joint moment opposite with member and moment, in the video this morning. Okay, referring to chapter number 11, slope deflection method. Okay, please watch that. So the moment that we distribute is actually the blue. Okay, the joint moment. So that is why the moment that we distribute is positive, not negative. Okay, so that is why in the table, okay, when we want to distribute, we put negative. Okay, because negative that we put in the table represent opposite condition of member and moment. Okay, so we have to total BA, the joint moment, BA plus BC. So this is BA plus BC. Okay, we times with distribution factor. Okay, distribution factor. We time with distribution factor. Okay, this. So we do the same for BC. It is total joint moment at B. Okay, times with distribution factor. And the total, okay, make sure after you have distribute the moment, so you get total 1, 2, 3, 4, okay, is equal to 0. Okay, so same thing we do to joint C, where we have to find the joint moment, which is CB plus CD, and I have put negative outside to representing joint moment, which is opposite with member and moment. Okay, joint moment times with distribution factor. Okay, joint moment CB plus CD times with distribution factor. Okay, so we have this. Okay, so total this must equal to 0. Okay, now we have to distribute moment. To carry over the moment. So in carry over, we have to consider the factor by considering n condition. So for n fixed and internal support, we have to use 0.5. For n pin, the factor is 0. So this is divide by 2. Okay, B we have to carry to A and to C. Okay, and moment at C we have to carry to B, and the factor for the carryover factor to pin is 0. So this one is 0. Wait. Okay. Okay, now we have to repeat again. Okay, we have to repeat again the process. So copy the value. Okay, so just check lah. Just check. This total of this must be equal to 0 and total this must equal to 0. We can check whether the formula used is correct. Time with distribution factor. Okay, this is correct. And we carry the value. Okay, and then we copy again the formula for distributing moment. Okay, check. Is it the total is equal to 0? This one also. And we carry over the value again. Okay, distribute again. Okay, carry again. Okay, distribute again. Okay. So we can stop whenever we reach 0.0 something. 0.0 something like this. So I want to stop at this distribution. So this is the total moment that we get from, okay, we get from table number 2, okay, which is side sway frame. Okay, side sway frame. So we get a negative 45 and 45, okay, representing MB is equal to 0, which is rigid joint, and 33.97 and negative 33.97, total is 0, representing rigid joint at C. Okay, so here is 0 because of pin support, and there is a moment at A, okay, which is equal to negative 72.82. So actually, so these are the two table. Table number 1 is come from diagram B. Okay, diagram B. Okay, and table number 2 is come from diagram D. Diagram D. So this value, so what we need to do with this value is we need to use this end moment value from both tables to calculate the value of R and the value of R prime. Okay, we need R and R prime in order to calculate the correction factor value, because we have made assumption to FEM value. So that is why we need to have the correction factor. The correction factor we get from the interpolation process. Okay, so wait, I need to copy this first. Okay, so the idea about, okay, what we need to do after this like this. Okay, we have two table. In moment distribution method for frame, I can conclude or summarize the process, okay, like this. Number one, step number one is we have to calculate K and DF as usual. This is step number 1. Step number 2, 2 is non-sway frame analysis. So non-sway frame analysis is, this is table number 1. So in this table, what we do is A, we have to calculate FEM. This is due to external load. External load. B, okay, after we have calculated FEM, we have to distribute moment. Okay, we have to do to distribute moment, or we have to calculate end moment from table. Okay, end moment. Okay, end moment, member end moment. This end moment we get from table. We get from distribution table. Okay, and actually we have another step. Okay, the third step in non-sway frame analysis is actually to calculate what is actually the value of restraining force. Okay, so actually this morning I have explained about this. I have explained about this. I have explained about 2A. I have also explained about 2B, but I do not yet explain about how to calculate restraining force. Okay, restraining force. Okay, and then just now I have actually explained to you step number 3, where we have side sway frame. Side sway frame analysis. This is table number 2, diagram D. And in this diagram, in this step, we have A FEM. But this FEM, we must assume FEM. Okay, due to delta. B, we have to calculate end moment. Okay, which is come from, okay, end moment in diagram. Okay, in the first table, in step number 2, this end moment is actually labeled as, this one is labeled as M naught. Okay, and for side sway frame analysis, end moment, okay, we call as M prime because we analyze all we analyze the moment in the table due to R prime, the delta is delta prime, so end moment is M prime. Okay, and C, okay, the restraining force. Okay, the restraining force in this case is R prime, not R. R prime. So the R prime is not shown yet. Okay. So now we want to, okay, I have explained about this. I have explained about this. Okay, step 2C and 3C is actually the same step. The same step. We have to analyze the frame using static equilibrium in order to determine the restraining force value. So what we need to do in this step is including shear analysis as well as column analysis in order to calculate R value, because the concept is like this. This is actually the concept. Okay, it comes with the first diagram like this. Okay, this is just the concept. Okay, the first diagram like this. Okay, we divide into 2. We divide into 2. We put, okay, this is P. This is example concept. This is P, external load. We have put R here. Okay, plus this. Okay, R in this direction. This is actually the concept. Okay, the first diagram A ni, there is a combination of P plus delta. And the second diagram, P only and delta only. So this is what actually we do for frame analysis. Okay, whenever frame, okay, the frame is side sway frame, we divide the system into 2. So the moment that we calculate, the end moment that we calculate in table number 1, we get M naught. I label as M naught. And due to R and due to delta prime, mana dia? Okay, due to R and due to delta prime, okay, we'll produce the moment called M. The moment called M. Of course, okay, this is B. This is C. Okay, of course, what we want is actually the moment here. I put as M final or M total, doesn't matter, just a symbol. Okay, M total. So what we want is actually MT, M total. And M total is equal to M naught plus M. And M naught we get directly from table number 1. M naught is the end moment we get from table number 1. But we don't have M. What we have is M prime. Okay, let's look at M and M prime diagram. So we have two diagram. Okay, this is R prime. And another one is the frame subjected to R prime. So between these two diagram, we have M and M prime. We have delta and delta prime. Okay, so we have two frames, so we have to interpolate. Okay, what we want is actually M and R, M prime and R prime. Okay, M. Okay, we want the value of M. This is what we want. But we don't have M. What we have is M prime from second table. Okay, of course we can calculate R prime from second table. And R value, okay, R value we get from table number 1. We get from this because R, these two R is the same R. Okay, is the same R in different direction. So from these two diagram, we interpolate M, MR, M prime and R prime. So what we get is M is equal to M, not M, R. Okay, it is R, not R prime, R over R prime times with M prime. R divided by R prime is called as correction factor. So actually the formula to calculate M total is actually M naught, which come from table number 1 plus correction factor R divided by R prime times with M prime. Okay, where this is N moment from table 1, this is N moment from table 2. Okay, and R divided by R prime is the correction factor. So this is actually the formula. This is actually the formula we use to analyze. Okay, we use to analyze member and moment inside sway frame. Okay, inside sway frame. So in order to calculate R and R prime, we use static equilibrium. Okay, we use static equilibrium to calculate R and R prime. Okay, what we need to do is, okay, we have to draw back the frame. The frame, this is the frame that we use to analyze N moment in table 1. This is R. Okay, and the moment that we get from table number 1, yang ni. This is all the moment that we have calculated. Okay, it is 1793.63. 1793.63. Okay, this is the moment. And then this one is 0 because this is pin support, right? This is fixed, so there will be the reaction like this. Okay, and then we have frame, which the second frame, the second one. Okay, the second one, due to R prime, of course we have this as well. Okay, the moment that we get from second table is negative 72.85. This is negative 72.85. Okay. Okay, what we need to do is we have to do shear equation. We have to write the shear equation. Okay, shear equation for column, for frame number, okay, this is frame number 1, this is frame number 2. The shear equation for column, for frame number 1 is, so we label all the free body diagram, the reaction. So this is AX, this is DX, this is AY, this is AY. Okay, the shear equation for number 1 is equal to, okay, shear equation is this, total Fx equal to 0. Total Fx is equal to 0. So we have to write all the horizontal forces, to include all the horizontal forces in the diagram. We have AX, minus DX minus R. And we have 750 here and 7 meter here. So the area, it is in, okay, positive 1 over area. The area of triangular. The area of triangular is 7 times 750. Okay, this is actually the shear equation to calculate R value. So R value is actually AX minus DX. Okay, it is 750 times 7 divided by 2. It is 750 times 3.5. Okay, it is 2625. 2625, because we have bring R to the other side. So this is the shear equation in order to calculate R value. In order to calculate R value. Okay, so our job now is to calculate what is AX and what is DX. What is AX and what is DX. So AX and DX we can calculate using what we call as column analysis. Column analysis. Okay, column analysis, apply. So this is A, this is B. So this is 7 meter. Okay, 7 meter. This column is subjected to this loading 750. Okay, the moment, the internal moment that we get from table is, okay, yang ni. Okay, so the moment that we get for AB is negative 1793.63, and the moment for BA is positive 700.10. So we have to calculate this value, okay, by taking moment at B. Okay, this is not completed yet because we have AX here. Okay, we want to calculate AX, so we have to, okay, we have to, okay. Okay, we analyze this using static equilibrium. This is just like we analyze simply supported beam. Okay, what we should do is we take the moment equal to 0 at B so that we can have AX. So it is 700.10 minus 1793.63. Okay, we have to minus 7AX, and then we have to minus also the area 750 and 7, and the centroid is 1/3 times 7. Okay, 1/3 centroid kat sini. Okay, so this is equal to 0. This is equal to 0. So we will get AX value. So AX is equal to, so this is 700. It is 700.1 minus 1793.63. Okay, and this is equal to 1093, negative 1093.53, negative 1093.53. Okay, and then we calculate another one. It is, okay, 1/2 times 750 times 7 times 1/3 times 7. Okay, this is 6125. 6125 minus 6125 minus 7AX is equal to 0. So we get AX is equal to, so we get this negative 1093.53 minus 6125. Okay, we divide by 7. So we get negative, means R is equal to, this is AX. AX is equal to negative 1031.22. 1031.22 kilo Newton. This is for AX. So we should do the same for column CD. For column CD. So column CD is quite straightforward. This is D. So for column CD we have, this is DX. The moment for C, this is the moment. Two oh 5.88. 205.88. This is 7 meter. Okay, the moment is positive 205.88. So using static equilibrium, taking moment at C, which is equal to 0. So we get 205.88 plus 7 dx equal to 0. So dx we get 2. It is 205.88 divided by 8. Okay, we get 25.735. It is negative. 25735. 25735. This is kilonewton. So these two value, we need to substitute into the shear equation. Okay, the shear equation. Okay, this is the shear equation that we get. Okay, the shear equation. Okay, so R is equal to AX is negative 1031.22. Okay, DX is negative is positive plus 25.735 plus 2625, and this is equal to negative 1031.22 plus 25.735 plus 2625. Okay. So 1619.515. 1619.515. 515 kilonewton. So this is actually how we calculate R value. So for second table for R prime, actually we should do the same process. It will be easier than this because there's no triangular load like this. So this okay, this concept of identifying AX and DX actually you can find in under topic number 11. Okay, the concept about this. Okay, so this is how we analyze R value, and we should do the same to analyze R prime value. And after that, after we have determined R prime value, we will substitute into this equation. So M naught we get from table number 1 is N moment, the total moment that we get from the table M naught. M prime is we get from table number 2. This is N moment from table number 2. But we have to have the correction factor, which is R and R prime. Why we have correction factor? Because table number 2, the FEM that we made is actually assumption. We do interpolation. Okay, interpolation to actually relate between M and M prime, and R and over R prime also we get from interpolation. So our task after we have done table 1 and table 2 is actually like this. Okay, so repeat the process that I have shown to you in order to calculate R value. Just repeat the process to calculate R prime value. Then we will get R prime. So after that, we can put into the formula based on the principle of superposition to get the M total. To get the M total. This is how we analyze the frame with such way. Okay, this is actually good example because this is just unique example, because if you see from table number 1, we have the moment like this, because we get FEM which is come from column AB, then we have to do distribution process until we get N moment. Okay, N moment. But for table number 2, we get from assumption. Okay, we get from assumption, and then that is why we have to do the interpolation process, and we have to find the correction factor in order to solve the N moment, the total N moment. Okay, this is actually the process of analyzing frame. Okay, analyzing frame using moment distribution method. Okay, so I hope you need to watch the first video in order to understand the second video. Okay, and this is actually the knowledge about moment and moment, fixed end moment, member end moment analysis using moment distribution method is very important. Okay, this is actually you can find so many video explaining about this. Okay, basically, for those who have learned this previously in diploma, maybe I don't think so. Maybe you have only cover beam in diploma, but previous years actually, student who have actually you have student come from diploma have actually learned about all this in diploma, but in diploma level, what they did is just follow the step, just remembering the formula, not really understand what is the process behind the formula. So what I have explained in the first video and this video is actually the derivation of the equation based on the principle of superposition. And then the FEM, we have done FEM due to such way, which is based on assumption, because we do not know the delta value and we don't have to calculate the delta value. So what we want is only the final N moment. So this exercise is actually very good in the future actually, and you are so lucky because you don't have final exam for this topic. We have amend that one so that you can apply this for this semester only for your assignment, because basically whenever this is the final exam question, so many of the students cannot solve until the end, even though the process is same, and you just need to repeat the process again and again, except the loading is same. So because table number 2, for table number 2, so this is actually the same process that you repeat again and again. The value, the assumption that you made is also the same, negative 100. But many students decided not to do this until the end of analysis. So basically, this is the knowledge. This is the that you need to know as engineering student. Analysis of frame using moment distribution method is very important. Okay, I have my friend who is actually engineer in Rand Hill. After 10 years working with Rand Hill, he called me to check, okay, to check his design process, his design report, in order for him to submit for the professional engineer. And he was doing, he actually designed the what we call that, pelantar minyak dekat tengah laut. Okay, pelantar minyak dekat tengah laut, he used that design to submit for his professional engineer. And very surprised uh, because I actually do not know that actually in the design, he actually used moment distribution method to complete the design. So because saya pun tak ada exposure until design pelantar minyak dekat tengah laut. So very surprised. This knowledge actually engineer guna sampai tahap tu. So that is why this is very important knowledge, even though you tak nampak sekarang. So you will find it is actually very important in your near future. Okay, so that is why I have to cover things until this stage, so that maybe this knowledge is important for you one day. Okay, so so this is all about frame with side sway. This is actually the basic frame, because this is frame with vertical member only, not inclined member. Actually our coverage is not only this type of frame. We also cover frame with inclined member as well, but that two type of frame. So I will give you the video and the notes only for you to see. Maybe you need that information in your near future. Okay, so that's all for this video. So inshallah I will give you assignment after maybe the end of this week for you to continue about 30% of your total marks. Okay, if you have any question regarding this, you want to have short discussion or small discussion explaining about what we have discussed in frame analysis today. Okay, okay, feel free to invite me in your discussion. Okay, that's all. Thank you very much. Thank you for joining. Okay, assalamualaikum.